Alright, so here we have an example of modeling with linear functions. Now the first thing we need to look at when modeling with linear functions is there's two types of linear equations. There's slope-intercept form, which consists of y equals mx plus b, where m is the slope and b is the y-intercept. There's also point-slope form, which is of the form y minus y1 equals m times x minus x1. In this form, m is still the slope, and it consists of the point x1, y1. When we model linear functions, we're going to use one of these two equations. So, let's take a look at our first example. So here in example 1, it says the table shows the number of tickets sold for a concert when different prices are charged. So we can see over here that x is our ticket price and y is the number of tickets that are sold. Part A wants us to write an equation to model the situation, and then part B, can the model reasonably predict the number of tickets sold when the price is $85? Alright, so if we want to write an equation to model the situation, the first thing we want to look at is what we're given. Notice that we're given x and y values. Each of these can be represented by a point. So if I look at the 17 and the 450, I can really think of that as the point 17, 450, where 17 is my x and 450 is my y. I can then do the same thing when I look at the 20 and the 423. I can think of that as the point 20, 423. 20 being the x and 423 being the y. Now, in order to write an equation, if I go back up to the notes, notice that I do not have an intercept, but I do have 2 points. So I'm going to use point-slope form to make the model of the equation. So when I come back to the example here, we need to be able to find the slope using these 2 points. Well, the slope is going to be equal to my y1 minus, or my y2 minus my y1 all over my x2 minus my x1. Now, it really doesn't matter which ones I make my y2s and which ones I make my y1s. I just got to make sure that I plug them in correct when I find my slope. So for instance, I'll make this my x1, this my y1, this my x2, this my y2. Okay? Now to find the slope, I just plug those numbers in. So for y2, it's going to be 423. For my y1, it's going to be 450. And then for my x2, I have 20. And for my x1, I have 17. At this point, I can simplify both the top and the bottom of the fraction. So 423 minus 450 is going to be a negative 27 over 20 minus 17 is 3. And then if I take negative 27 divided by 3, I get negative 9. Okay, so my slope is equal to negative 9. Okay, now, once again, if I think about my 2 equations that I'm using, right now I'm focusing on using point slope to model this. In order to use point slope, I need both a point and a slope. Well, if I look at what I have so far on the problem, I have 2 points and a slope. So to write it in point slope form, I just need to choose one of the points, doesn't matter which one I choose, and then use the slope. So for instance, I could write this equation as y minus my y1, well, my y1's 450, and then that's going to be equal to my slope of negative 9 times my x minus my x1, well, my x1 is 17. So this would be the equation. Okay? Now, with this equation, so part A, to write the equation to model the situation, Once again, my equation is going to be y minus 450 equals negative 9 times x minus 17. That's the equation. Part B says, can this model, this equation we just found, can it reasonably predict the number of tickets sold when the price is $85? Well, if we look at the ticket prices we used to make the model, notice that they're 17, 20, 22, and 26. None of those prices that we used to make the model are very close to $85. So because the model is based off low prices comparable to $85, we cannot predict very accurately how many tickets are going to be sold based on our model. Our model is going to work better when we use prices that are closer to the numbers that we made the model with. So when answering this question, can the model reasonably predict the number of tickets sold when the price is $85? The answer to that is just simply no, it can't.